Integrity constraints. So what are integrity constraints in database? So integrity constraints are used to specify some rules for a data in the table. So we have data in a table and we wanted to have some specific rules on that data, that we call it as constraints, SQL constraints. And these constraints can be specified when the table is created, or even at the later point of time also we can actually use alter table command to actually have these constraints on the table. So that is what we call it as a constraint. Constraint is something like a condition, or it's a rule on your table data. That is what we call it as an SQL constraint. So we'll see what are the different constraints we have in SQL. You can see it here. Not null is one constraint which ensures that a column cannot have a null value. If we wanted a column, we create a table, and what do we say? Like while creating the table, we specify the column data type, and data size. That is what we specify for each column in a table we wanted to define. And along with that, if we wanted that column to have definitely a value to be given to that column, then we can specify that column as not null. Next, unique ensures that all values in a column are different. If we specify a column like column name, data type, data size, and if we specify that column as unique with this keyword unique, then that column allows only unique values. You can't actually have duplicate values into that column. We will get an error if we try to have the duplicate values. Next, primary key. Primary key is a combination of a not null and unique. So both the combination of not null, it has to be like a not null, and it should be unique. The combination of both is what we call it as a primary key. And this is the keyword. Like if we wanted to have any column as primary key, so we can define it as primary key, and with this primary key we can uniquely identify each row in a table. And what's the constraint for this? Not null plus unique. So it will not accept null values, and the values which are to be entered for this column, which is defined as primary key, should be unique. Next comes foreign key. Foreign key is it is used to uniquely identify row in another table. So we'll discuss this in detail. What does we mean by in another table? So next, check constraint. Check constraint is ensuring that all values in a column satisfy a specific condition. So we'll write some check condition, and only and while inserting or performing some DML operations, so this we will be verifying that check constraint, whether that constraint is followed or not. Default is used to set a default value for a column. So say for example we define some column, and we can have some default value to it, so that if even if we miss providing the value to that column, that default value will be assigned to the column. These are the different integrity constraints or SQL constraints we have in SQL, and we are going to discuss these constraints in detail now. First of all, not null. Not null is a constraint which will not accept null values. So what did we discuss about null values? If you remember, null is something like missing value. It is not empty. It is not an blank. It is not a space, but it's just a missing value in your column. That is what we call it as a null value. And not null can be applied on any number of columns. So this is the syntax. You can see it here. I have a table called student. How do we define a table? Create table is the syntax we use to create a table. Create table student, and I wanted to have 3 columns: S number, student number, which is of integer data type, and then we can specify not null here, so that definitely a value should be provided to this column when we are inserting row into this table. And it has student number, which is varchar, and marks, which are integer. But I wanted to have my student number as not null. So definitely we need, whoever is inserting a row into this table student should definitely provide S number, that is student number. That is what this not null constraint says. And you can see it here, an example. Let's see this now. Let's create this table. with not null column. Okay, I think I already have it. I wanted to create this table in my testdb schema, so I'm saying use testdb, so that it will point to the MySQL knows that whatever we are doing now will all like considered into this testdb schema. Now create table student, same s number integer not null, student name, some varchar and marks integer. So I am creating a table student with 3 columns, and in these 3 columns my student number is declared as integer, and I am providing the keyword not null, so that what happens is whenever we are inserting data into the student table, inserting or updating, definitely this s number should be provided some value. We should not miss value for this column. So let me create the table first. You can see table created successfully. Just go to your tables here in testdb schema, refresh it. You can see your student table here. Now let us actually execute one, insert one row into this table. Insert into student values. This is how we insert any row or record into a table. So I am assigning 100 to student number. Smith is the student number. 65 is the marks. Let me execute this statement. So it is affected. Now let us verify the data in the student table. This is how we read the table data. Select star from student is my table name. And we can clearly see the row which we inserted just now got displayed. All right. Now what we'll try here is we wanted to try inserting null into s number column. So this is what we discussed, right? As this was defined not null, this is not allowed. Sending null or missing this value is not allowed. So let us try this. And you can clearly see it says column s number cannot be null. So why did it said like this? So if we don't have this constraint, even we can provide null values as well. This would have been executed successfully. But as we had this constraint of not null, we are getting an error saying column s number cannot be null. So you can't have this. You should definitely provide some value to this s number, as not null constraint has been imposed on that column s number. This is about not null, and we can have this not null constraint on more than one column as well. So say for example, if we wanted s name also to be not null, definitely some value has to be provided for student name. Then we can have not null constraint defined on s name column as well. This is all about not null constraint. Next, unique constraint. So unique is a constraint which will not allow duplicate values. So unique will not allow duplicate values. Whenever we wanted to a column to accept unique values, then we can define that column as unique. So this is the syntax of it. And it can be applied at column level and table level. So what do we mean by column level and table level? So you can see it here. Create table student, student number, integer. Then we'll specify the keyword unique. And this need not be uppercase. This is case insensitive. Just to highlight that we are using this keyword, I gave it in uppercase letter. And then you can see student name, varchar, marks integer. This is same, but here we wanted student number to accept only unique values. In that case, we can specify that column with unique constraint like this. And this is at the column level. And we can specify the same constraint at the table level as well. So this is the syntax of it. Create student one. So we are not going to specify the unique constraint immediately after the column is defined, but we'll define all the columns. Then finally, once we are done with defining all the columns in the table, at the last we can specify unique of s number, which says that s number or student number is unique. So this is another way of like defining unique constraint on the table. This is at column level as we specified this unique constraint immediately after defining the column. And once we define all the columns, then if we specify the unique constraint, that is what we call it as a table level unique constraint. Now we'll create a table. Let's create a table with the unique constraint. We already have student table, right? So let's create it with student one now. And table got created successfully. So it should have 3 columns and student number should be unique. It can't accept, it will not accept duplicate values. So let me refresh these tables. You can see student table 1 here, student 1 here. And now we wanted to insert some values into it. Sorry. Let us insert first record. So you can see I am providing some value to the student number, student name and marks. Let me execute this statement. Fine, it executed successfully. Now we wanted to look into the data from student one table. You can see the data has been displayed. We are able to successfully create the table with unique constraint. We inserted a row and we also able to read that data from the student one table. Fine. Now let us try to insert another row or record into the same table, but this time if you observe, I am trying to insert the same value for the student number which already exists in the table. So now let us see what happens. And you can clearly see there is an error. So you can see here in the bottom, there is a window called output. And here you can see it is indicated with cross mark, red cross mark. And in the message, you can see what's the error. Duplicate entry 100 for key, student one dot s number found is what it is saying. And this is an error. So why we are getting this error is as we have unique constraint defined on the student number column. So once there is a number or there is a value for a column which has unique constraint, that same value can't be used again for any other record. That is what is about unique constraint. And we can have null values. Remember, we can have null values. Even though my column is defined as unique, I can have null values and I can have more than one null as well. Let us execute this statement now. So you can see this query got executed successfully, and even we can see the data as well. You can see S number can be null. So also let me insert another record. So you can see I'm inserting null David some 80 as my marks. This also got executed. Now let us view the data. So you can see there are like 2 records inserted and these have S number as null. It is accepted. So whenever we define our column as unique, duplicate values will not be allowed, but null values can be are allowed. Just remember that. And we can have any number of multiple null values into the column which is defined as unique. But if we provide some value that can't be duplicated, it can be null and you can have any number of multiple null values for that column. This is all about unique constraint. Next, primary key constraint. So what is primary key? Primary key is just a combination of both unique and not null. So unique, what did we learn? Unique has, if a column has a constraint as unique, then that column will not accept duplicate values. It can accept null values, right? But primary key is like combination of unique plus not null. Not null is it can't have null values. So if you combine both, like unique is like accepting only unique values, or it will not accept duplicate values, plus not null. It can't be null. So this combination we call it as a primary key. And primary, so you can see it here. Primary column, key column will not allow duplicates and null values as well. And another thing is a table can have only one primary key. We can only have one primary key for a table. So unique, it can be applied for multiple columns for within the same table. And not null also, we learned that it can be applied for multiple columns within the same table. But primary key can't be applied on more than one column in a table. And primary key is used to uniquely identify a row in a table. You can see here, primary key constraint can also be created at both column and table level. So you can see column level, how do we define it is create table, table name, student number, integer. Then we just need to specify the constraint here as primary key. And then what are columns if you wanted, we can define the more columns into that table. And this is how we define primary key at the column level. And if you observe, this is how we define the primary key at the table level. So this is the primary key defined at the column level. Column level in the sense, once we define the column, there itself will define this constraint that saying that this column is primary key. And table level is just like we define the table, we define the columns in it, and at the end we'll define what is the primary key for that table. And this is the syntax of it. Let us see an example on this. Let me create the table. So this time let us create with the table level constraint. Just for variation, I'm creating table this time with table level constraint. Earlier we declared it, we created with column level, right? Unique. So I wanted to create it at table level now, this primary key. So you can see I am creating a table student2 with same like a student number, which is integer, where I wanted this column to be my primary key, student name and marks. And at the table level in the sense, once we define all the columns, at the end we'll specify what is the primary key for that table. So primary key of S number, meaning I wanted to make my S number as primary key for this table. Let me execute this create table command now. Let us refresh these tables. You can see student table 2 got created, and you can also see here columns S number, integer pk representing primary key. Pk represents primary key. You can also view it like having describe student2, execute this statement. You can see it here. When we describe this table, we can see the structure of this table. It has three fields. S number is of integer type, null, no. So we didn't have null constraint, so it is saying no, but we defined primary key as primary. So which means that anyway it's the combination of unique and not null. And you can see the other columns as well. So these can accept null values is what it is saying. All right, now we created a table with primary key as student number on this table, right? Now we wanted to insert some data into that table. Let's do that. First, let me execute this and show you. This is student2 table and we don't have any data in this. Let us insert some data into it. Let me take this rows. Now, first let me execute this, insert into student2 values, some value into the student number, student name and marks. So let us execute this statement first. So this is executed successfully. And we can see the data here clearly. So don't get confused with these nulls here in this row. This is coming from MySQL Workbench. MySQL Workbench provides you the last row as all nulls so that you can directly provide the data here if you want to insert it from this UI. So this is not the actual row which is inserted or which is already persisted on the database. Now we inserted one row, right? First row, fine. Now I wanted to insert another row. Observe now, another row with the same S number, same student number. Is this possible? As the student number is defined as primary key, what is the primary key? We just now learned. It's the combination of unique plus not null. It should not be null. Fine, it is not null. It has some value, but it is should also be unique is what we said. But it is not unique. It already has the value 100 in it. So this is invalid. Let us execute this and verify. And you can clearly see here the error. When we try to insert student number as 100, it's already there. A record with student number 100 is already present in student 2 table. So you can see the error here. Duplicate entry 100 for key student 2 dot primary is what it is saying. So student 2 S number is defined as primary, and it also already has 100 for that column is what it is saying. So this is invalid. Now let us try to insert null. And it says column S number cannot be null. But if you observe, we didn't actually define it as not null or unique. We just defined it as primary key, which has two features, unique plus not null. And that is what we have seen here clearly. So it can't accept null, and it will not accept duplicate values as well. So even this is this becomes like inserting null value to that column, which is defined as primary key, will also become invalid. And if you observe, we have only one row inserted into this table. This is all about primary key. So very important in the entry point of view, what is a primary key? So a primary key is a combination of unique values and not null. So a primary key will not accept not null. A primary key is defined as not null and unique. It will accept only unique values, and it can't have null values is what we should be answering. And another thing is a primary in a table we can only have one primary key. So only, let me put it here. Primary key is a combination of uniqueness plus not null. Cannot have more than one primary key for a table. We can create primary key and combination of two columns, but we can't have primary key defined on more than one column. But what we can do here is we can combine more than one column and make it as a primary key. So what does that mean is, say for example, you wanted to have both student number and student name as primary key. Then we can't have it independently saying that my student number primary key, comma, S name primary key. We can't have it like that. But what we can have it is, we can have the combination of them, like primary key. I'll show you the syntax as well. Primary key, S name, comma, S number, comma, S name. This is what we can have it at the end. So that what happens is the uniqueness will be evaluated by combining both S number and S name. That's how uniqueness will be evaluated. And this is how we can define primary key on more than one column. And when we have primary key defined like this, with the combination of more than one column, that is called as composite primary key. So don't get confused. We can't have independently primary keys for two columns, but on the combination of two columns, two or more columns, we can have the primary key defined. Still, we should be seeing it as only one primary key, even though we have the combination of them. And that's the reason to differentiate them, it is called as composite primary key. So whenever you say that you have composite primary key on your table, that means that you have a primary key defined on more than one column. Is the meaning of composite primary key. Again, an important interview question. So what's a primary key and what's a composite primary key? What's the difference between them? And composite primary key can only be applied at the table level. Just now we have seen that, right? So this can only be applied at the table level. At the column level, it can't be applied. Like if you say primary key here at S number integer, and again if you say S name primary key, that is not allowed, as we can't have primary key defined on more than one column. But we can have the combination of columns and define the primary key on it. And what does this mean is, combination of this should be unique. So S number plus S name. So let me give you an example. Here there is 100 Smith, right? So if we have S number and S name as uniqueness, so you can't have both 100 and Smith again. So you can have 100, but you can have another value, some value here. So that's what we call the combination or composite primary key. This both should be like unique. So this is what composite primary key means. Foreign key constraint. What is a foreign key constraint? A foreign key is a key used to link two tables together. So say for example, we have two tables, and one table we have a primary key defined, and there can be another table where there is one column that will be referring or linking to this primary key column table. Okay, let me show you with an example. Say for example, we have some employee table. Employee table might have some employee ID. Let's say for example, employee ID, some full name, salary, and then department ID. Department ID to which this employee belongs. And remember, employee ID here is primary key to this table. And now I have another table called department, where I have department ID. I have department ID, which is primary key for this table, and there can be department name, some department location. These are the three columns for this table. Now this department ID, you can see here, department ID from employee table will be foreign key, will be defined as foreign key, and will be referencing the primary key of this department ID. So what does that mean? You can see it here, employee table has 4 columns, employee ID is primary key here, fine. And it can have some data here, table data, right? And when we say this department ID is defined as foreign key, which is referencing primary key of another table. So what's the meaning of this? So this is how we define a foreign key first of all. And what's the meaning of this is, you in the department table, department ID is primary key, meaning let's say for example, it has some values in this table. For department ID, say for example, it has 10, 20, 30, and it can have some department name and department location. Let's say for example, there are some values, but department IDs are like 10, 20, 30 in this table defined. Now, what does this foreign key referencing this primary key is means is, while inserting rows in employee table, this department ID should only have the values from this list, the list of values which are defined in this department table. So it can't have any other value like 40 or 50. It can't have these values out of this range. So it should only pick up from this list of values which are defined for this department table, which is defined as primary key. And why should this department ID should have only these values is, as this department ID is defined as foreign key and is referencing to the department ID in department table. So this is the meaning of defining a foreign key on a column. Now let us go back. Now let us read this. A foreign key is a key used to link two tables together. This is what we have seen now. A foreign key is a column or group of columns. It can even be a group of columns as well. Like how we define composite primary key. Like in the same way, foreign key can also be a combination of columns in a table that refers to a primary key of one column. You can see it here. A foreign key is a column in a table that refers to a primary key of one column in another table. So just now we saw primary key of another table is this is department table we saw, and a foreign key is a column. This was also a department ID which was coming from employee table, and this department ID which is a primary key is from department table. Foreign key is defined on the department ID column of employee table which is reference, which refers to the department ID of department table. So that what happens is always this department ID can have the values of the values which are listed in the department table. It can't have any other value which is not present in this department ID of department table. That is one thing. And you can see the table that contains the foreign key is called as child table. So we have foreign key, uh, the table that contains a foreign key. So this in our example, let me go back to our example. This is called child table. Wherever you have defined foreign key, this will be called as child table. And whichever has PK and which has been referenced by some other foreign key, this will be called as parent table. You need to remember this terminology. So why this is called parent table and why this is called child table. So child table, as we have foreign key defined in this for this column and which is referencing to some primary key in another table. So this which has been referenced is called parent table, which was defined as foreign key and which is referring to another column is called as child table. So this is all about foreign key. So it can be called as parent table or reference table. So the one which has the primary key. Now let us see an example on foreign key. So let me create a table first, a student table, which is a parent table. And you can see student table has student number, student name, and marks. And I am having primary key constraint on the student number. And we have another table called library, where it also has student number. And you can see here foreign key is defined at the column level, and you can see foreign key is defined for this S number, student number. And this is how we write the syntax for the foreign key. Foreign key, student number within the library table, references to which it is referring, student table S number. Because in the student table S number is defined as primary key, and here library key we have library table we have student number which we wanted to refer to this primary key, which we wanted to refer to this student table for the reference. And it can have any other columns, this library table. But the foreign key, we wanted to define one column student number, and we wanted to reference the values for this column from student table where the student number is defined as a primary key. Now let us create two tables and let's understand. First, let me create the parent table. So when we call this as parent table is when it has primary key and it will be referred later by uh, another column which is defined as foreign key from another table. I am creating a student table. I already have student table. Let me define it as student 3. I'm going to create this table. So we got table created successfully. We can see table created successfully with primary key as S number. And let me refresh this. You can see student 3, it's defined as student number integer. It is defined as primary key. Fine. Now let us insert some data into it. So I'm inserting some data here into student 3 table. And you can see as I defined primary key for my S number, I am giving unique values to this S number and providing some S name and marks here. Now let us view the data from student 3. So, okay, I think we need to commit it. Okay, sorry. It has to be student 3, right? The table name is student 3. I inserted into student. That's the issue there. So let me insert one by one record here. Now if I query for student 3, you can see it here. We have 3 rows in it. Fine. This is about creating like our parent table. Now we wanted to create a child table. Let's go to our child table. which is library table. So this is foreign key referencing. You can clearly see it here. Let me make it in uppercase. You just need to highlight this and press your Control Shift U is the shortcut which converts your whole query into uppercase. You can see create table library s number integer, and then we are saying foreign key. This is, then we need to specify what is the foreign key. S number is the foreign key from this table, which has to references to which this key has to be reference. It has to reference student table s number. There is a column s number in student to which this the s number or student number which is present in library table has to be referenced, is what we are saying with this statement. And there is another column called some book name. This is about library table, which we call it as child table. You can say this as child table as it has foreign key. Okay, let us create this child table now. Oh. Fail to add the foreign key constraint, missing index for constraint, the reference table. Okay, again, what did we do? Okay, again, like references student 3, right? This has to be student 3 table. Now let me create it. So you can see table got created successfully. Earlier I gave student, but we wanted to reference to the student 3 table, right? So I just give student 3 here and it got created successfully. Fine. Now let us query this library table and check. So this is the library table which has no data. We wanted to insert it now. Now observe. We wanted to, as library table has s number and book name, we wanted to insert some values into it. So we can insert, and the condition here is, if you remember, what was the condition? It has to have the values which are present in the primary key, which is it is referencing to. So it is referencing to the student 3 table primary key. You can see it here, 100, 101, 102. These are the values. So we should be providing only these values to this foreign key in this library table. And you can see here, that's what I'm following here. You can't provide some other value here, like some 50, 60, like that, as that value is not present as primary key here in this student 3 table, as that is what foreign key definition says. So as foreign key, this s number is referencing to student number s number. So always this child table or library table should have values which are already defined for the primary key in student 3 table. Now let me execute that. So I am following that constraint and inserting a value. As 101 is already present in this parent table student 3, I am using that same value here. For that student, I am having a book here. And you can see it got inserted successfully. No issue, fine. Now let me execute another row. And again, you can see S number, I am following the foreign key constraint. I am providing the value 102 or the value which is already present in the student 3 table, which is called as parent table. Let me execute this statement. And again, it is successful. Let us query this library table. You can see it here. Successfully 2 rows inserted. Now, what we'll do here is, we'll try to insert a row with the S number, which is not present in the parent table. It has 100, 101 and 102, right? So I'm going to insert one value for student number, which is not exist in the student 3 table S number. Now see what happens. So you can clearly see it says cannot add or update a child row. So it says clearly, okay, let me get this. Copy, copy row. I'll just say here like this. And you can read the error here. Error code is some error code, and then you can see cannot add or update a child row. I am not able to add a row or update this child row, whatever you wanted to trying to do. as a foreign key constraint fails. There is some foreign key constraint on the library table. uh, it actually assigns some constraint name, foreign key constraint name by default. That is what it is showing, and it is clearly saying foreign key S number is referencing to student 3 table S number. That's why uh, this constraint is violated and this record can't be inserted is what the error is saying. So this is all about foreign key constraint. And one important thing here is, before having this foreign key checks, we need to set this, set foreign key checks equal to 1. This will by default be 0. So you need to execute this command. As I already executed this in my session, so I didn't do this, but in your case, you will be executing this command once. Remember that, set foreign key checks equal to 1. Otherwise, this foreign key constraints will not be enforced, meaning this statement will also be executed without any issue. But we wanted that foreign key constraints to be enforced, right? So for that, you will be saying this, will be executing this command, set foreign key checks equal to 1. Execute this once, then execute this, create this library table. Only then the foreign key constraints will be enforced. This is all about foreign key constraints on the insert part. On the deletion part, we need to know something. Say for example, we have some primary key and foreign key defined. Now I wanted to delete, for some reason I wanted to delete some row in my parent table. So what should happen, as the child table is referencing to the parent table? So what should happen to the child table column values now, which are defined as foreign key? So that becomes ambiguity now, right? So for that, actually that will not even be allowed. If you directly start deleting the parent table rows, so you can't delete it. So you'll get a constraint error there, saying that you can't delete the parent table unless and until you delete all the rows which are referenced by the child tables is what we'll get. So usually what we do here is, say library is a table which has the foreign key constraint on S number, which is referencing to the student 3 table S number, right? In this case, say for example, I wanted to delete this 101 from my student 3 table, but we can't delete it directly. So what error we get here is, so let us try that. Delete from student 3 where my S number equal to 102. And you can clearly see here, cannot delete or update a parent row if foreign key constraint fails is what it is saying. So why it is saying like that is, there is some other table, some child table which is referencing to this value. So first delete this row, then you are allowed to delete this row is what it is saying. Not so in our case, it is only library table which is referencing to S number of student 3 table. So say for example, if you have some 10 or 12 tables, like each table has S number and is used as foreign key, and which is referencing to the same S number from student 3 table. So in that case, that will become a tedious job for us, like to go to each table and delete the child, locate the rows. Not only if you wanted to delete one or two, then you need to write a condition, delete from library where S number equal to 1 or 2, and you need to repeat it for all the tables wherever it has 1 or 2 as the S number. Then once you are done with all the deleting this 1 or 2 as S number rows, once you are done with deleting all these rows from all the 10 tables, then we can come back and we can delete it from the parent table. But if you see here, that becomes very tedious job, right? So what is the solution then? If there is a parent key and foreign key constraint, so the solution here is, we can use on delete cascade. So there is something called on delete cascade option, which we can define it when we are defining the child table itself. Like say for example, earlier we didn't have this, if you observe. Now we are going to have this at, like after defining foreign key, and you can also see it is now foreign key is defined at the table level. Earlier we defined it here itself after defining the column S number, And you can see this time we are defining a foreign key at the table level, and then we'll say something called on delete cascade. So which says that on delete cascade in the sense automatically when a parent key table is, or when we are deleting some row from the parent table, automatically delete the corresponding rows from the child table is what it says. This is the use of on delete cascade. So now let us create this parent table again. This is the parent table and it is student 4. Let me name it as student 4. The same table again, and wanted to insert some rows into it. I inserted 3 rows into it. Let me check the data in it. Student 4, right? We inserted 3 rows into the parent table. Fine. Again, I missed this as student 4. This has to be student 4. And we can see it here. We have data in the parent table. Fine. Now, the only change here is in the child table, right? So let's create a child table as well. So this time I'll name it as library 1, which is referencing student 4. Student 4 table. And the only new thing to us here is on delete cascade. So we are specifying this option so that whenever we wanted to delete a row from the parent table, so it will automatically delete the corresponding child rows which are referencing this parent row. So let me execute this now. Now library 1 table got created. So let us do select star from library 1 table. So there are no rows in it. Let's insert some rows into it. And observe, I am only inserting valid values like 101 and 102 are already present here in the child table. So I am only inserting that rows. Why is it? Okay, let us insert one by one. First row, second row. It says you have an error in your SQL syntax. What's the error? Okay. The single quote was not correct. It was some junk character. Now let me execute it again. All right. And you can see I can have duplicate values for the foreign key. Like this is just referencing, foreign key is referencing the primary key. So the only constraint here is it has to be some value which is already present in the primary key. It need not be unique. We can use same student can have more can register for more than one subject or can read more than one book, right? So that's the concept here. So 102 is the student who has the book Java. Same student can also have C++ as well. And but the only constraint for the foreign key is this value has to be present in the primary key which it is referencing to. So now we inserted all the 3 rows. Let us check. It has to be library 1. And you can see library 1 has 3 rows in it. Fine. Now what we are going to do here is I am not interested to, like, I wanted to delete the student with S number as 102. And what should happen now? 102 was referenced in another table, library 1, where it was called as foreign key. And what should happen, these two rows, it should automatically be deleted. That is what our expectation. Let's try that now. Delete from student 4 where S number equal to 102. Observe now what I am doing, deleting it from parent table student 4. And let's first verify this tables. Student 4 has 3 rows, 101, 100, 101, 102. And library 1 has also three rows. Remember that. Now I'm going to delete a record from student 4 table with S number equal to 102 successfully deleted. Now let's first check student 4. So student 4, 102 row got deleted, fine. But how about the foreign key table or child table? Let us execute that now. So you can clearly see child table or library one table has only one record now. It used to have three rows. So 101, and there was like two rows with 102. We just know inserted, right? These two rows got automatically deleted from the child table, as that doesn't make sense, like having them in the child table without having them in the parent table, as that again violates the foreign key constraint. And this we were only able to achieve when we had this on delete cascade option defined at the foreign key. This we need to remember, and this is also very important. And this we covered just now. One row deleted from parent table and two rows from child table also deleted. We covered this. Check constraint. What is check constraint? So check constraint can be used to enter specific values into the column. So we can have a restriction on what are the values to be inserted into a column. So that we can do it using check constraint. And the syntax here is create table. Let me put this into the editor. You can see here create table. Let me name it as student 5. You can see student number integer, s name fine, marks integer, but you can see we are going to have some constraint on the marks column. So the value which marks column will be taking, on that we wanted to have some constraint using check. So what does that mean? So we are writing some condition here, marks between 40 and 100. So whatever values you are going to insert while inserting a row into this table, for this marks column, the value should always be 40 and 100 is what we are saying with this check constraint. So this is what check constraint is used for. And this can be used to actually define any other conditions as well. If say for example check, and then you can specify some other condition, like we can give the list of values saying that it has to be one of these values, like that we can have any other condition as well. But here in this example, my condition is to have the marks only between 400 and 100. So let me execute this. We created a table. All right, we created a table now. Now we wanted to insert some rows. Let us insert some rows into this table. See, I'm inserting 100 as the um, student number, some name, student name, marks as 70. As 70 falls between 40 and 100, it has to be inserted successfully. And here we can see when I executed the statement, it executed successfully, fine. Now observe, I am inserting another record where S number is student number is 101 and some student name, and observe here, I am giving marks as 35. But there is a check, there is a constraint using check which is saying marks has to be always between 40 and 100, but 35 is less than 40. So what should happen now? Let us see that now. It has to, okay, it executed, or okay, just a minute, let me execute this. Okay, again it is student 5, right? I missed this. All right, let me execute the first row. Fine, it executed successfully. Now I wanted to execute second row where I have like I wanted to insert marks as 35, but that is violating the check constraint, which allows values between only 40 and 100. So let me execute this now. And clearly it says check constraint. There is some constraint it created automatically implicitly. That is what it is saying is violated. This constraint is violated. Check constraint is violated as 35 is less than 40. And it is expecting this check constraint for marks is expecting the value between 40 and 100. And in the same way, if it is like more than 100, let us execute this. Again, it says check constraint is violated. So it has to be between 40 and 100. Only then it will allow the value. This is what the check constraint is used for. And another example, let us create another table called location, which has city, country, and postcode. There are three columns in the location table. City, it is defined as varchar, and we have a check condition. So what is the check constraint here? City in these are the list of values. So you, while entering the value for city, it has to be any one of the values listed here. Other than this, if there is any other city, uh, someone tried to enter into this location table for the city column, then that should be like a thrown error saying that this check constraint is violated. And what's the condition here? City in the sense the list of values, it has to be one of these values is what our check constraint here is. So let me execute this location table. It got created successfully. Now let me insert some rows into it. First row, if you see, insert into location values. So city, I'm providing some city which is already exists in this list. So one of the cities mentioned in this check constraint, I'm providing that city here. And country, there is no constraint or no check constraint on country and postcode. I can have anything. So this is valid and it has to be executed successfully. Yes, it executed successfully. Let me execute this. You can see one row got executed successfully. Now observe second row. What I am doing here, I wanted to insert a city called Paris, which is not present in this list. Let us execute this now. Then we will get a error. Check constraint is violated as this city Paris is not present in this list of values. And last row. So you can see Delhi is present in this list. So this has to be executed successfully. Yes, there is no error on that. And you can see two rows got successfully inserted into it. And the only constraint here is city should have one of these three values. Only then we can insert the data into this table or update the column city value with one of these values. This is all about check constraint. Now, default constraint. What is default constraint? So default constraint is used to provide a default value for a column. The default value will be added to the column if no value is specified. So while inserting a table, inserting a column value, if we do not specify any value, the default value which we defined at the table creation will be assigned to that column. So say for example, we have some table called orders, which has ID as a column, which is integer, order number as integer, order date as date time. Date time is one of the data types. Order date time is the data type of that column. And you can see here, default is what we are defining it here. So what does default means here is, so it says it is the default value. What is the default value? You can specify some value here, but we are using function called now. So when we are discussing built-in functions in SQL, we discussed this. Now actually returns the current date and time, current date and time, current date and time is what it will return, now function. So this is what we are using it as the default value for this order date column. Let me create this table. I created a table called orders, fine, with 3 columns. You can see it here. Let me refresh this. There is an order table which has ID, order number, and order date. And you can see here order date column. I define it as default, and specify whenever we specify default for any column, we definitely need to specify one value as the default value. Here in my case, what I am doing here is as it is date time data type, I am just using now function, which actually returns the current date. Now let us insert some records into this table. So insert into orders, I am providing, if you observe, ID and order number. I am not providing any value to the third column, which is order date. Okay, we need to specify one more value, right? Order number. This is, say for example, we'll provide some 200 to the ID, and we'll provide some 300 as the ID. So you can see here there are 3 columns: ID, order number, and order date. We are providing ID and order number, only two values. Third value I'm not even providing for the third column. You can see it here. So what happens if we do not provide any value? That we are going to see now. Let me execute select star from orders. So we have a table now without any data. Now I am going to insert first row into the table, and you can see one row affected. And if you observe, we had three columns in this table, but we provided only two values for two columns, ID and order number. Third column, we didn't even provide the value for it. But now let us check this table data. So you can see here, order date, we didn't insert this. But how did this order date got the value? So this is because of this default constraint on this order date column. So the default, we are specifying the default value as now. Now function returns the current date and time. So that's the reason it is printing this. Now you can in the same way, like let me insert one more record into it. So inserted successfully, and you can see here. Here also I provided only two values for the two columns for this table. Third column value it picked up for the default value. It need not be always on date time even. So default can be defined on more than one column at a time in the same table. So if you wanted to generate ID or order number, if if nothing is provided to that, so you can just specify something like this default. If order number is not specified after the data type, what we can do here is we can just specify like this. If someone doesn't specify the order number while inserting the data, if I specify like this, automatically this 999 will be assigned to that row. So this is how we can use default constraint to provide default value when no value is provided for that record. This is all about default constraint. Next is auto increment. So what does auto increment do? Auto increment is a function that usually operates on the numeric data types. So what does it do is it automatically generates a sequential numeric values each time when a new record is inserted into a table for that field which we define it as auto increment. So what does that mean is, let me show you. Let me first define the table. So you can see here, create table student. We are going to create a student here with the student number integer, which is primary key. We are having primary key constraint here, and observe here we are using a keyword called auto underscore increment. So what does that mean is, and there are some two columns, student name and marks, but let's concentrate on this column first. So this is student number, which is of integer data type and which has the primary key constraint, as well as some keyword we are using it as auto underscore increment. So what does that mean is, we are not going to provide any value to this, but MySQL automatically should provide the value which like each time, but if it provides some value which is already there, its primary key, it will not allow. So that's the reason we are using auto increment. What does that mean is, we will specify some starting value using this statement, alter table name auto increment equal to 100. So when we say this, what happens is, let me execute this. So when we say this, on this student 6 table, yes number column, value should start from 100 and it should be incremented by 1 each time. So with this, what happens is, whenever we insert some data into this table, even though you don't specify S number here, you specify only name and marks, it will this column value will automatically get the value incremented each time starting from 100. That is what auto increment is. So let me show you how it works. I wanted to insert 3 records into this table. And if you observe, we are not specifying all the column values for all the columns. We are specifying only S name and marks. S number I am not specifying here. If you observe, S name is varchar, so gave it in single quotes. Then marks, we are not specifying S number here, and but we executed this statement. So we said, like, we gave hint to MySQL that the S number should start with 100. So what happens now is, when I execute the insert statement, let me write the select statement for student 6 table. Let us see. Okay, we didn't create this set. Okay, let's create this first. Then altering the table to have auto increment values should start from 100 is what we are seeing. And you can see there are 3 columns which doesn't have any data. Now observe, I am inserting a row into this table but I am providing only 2 values, student name and marks, not providing student number, which is an integer data type, and it also has primary key constraint. But we had something called auto increment, and we assign the value as 100. Now let us see what happens. So without any error, a row got inserted into it. Let us see the data in it. And you can see we didn't provide S number as 100, but S number got inserted successfully. Now let us insert second record. Here also I am not providing S number if you observe. So again, row inserted successfully. Now if you go and view the data, it automatically got the S number as 101. So what happens here is, each time when you insert a record into this table, this S number will automatically be incremented starting with 100. So we already inserted 2 records. So we already got 100 and 101. So if I insert third record, it will automatically take a new value which will come after 101, incremented by 102, and will assign that 102 value to this new record. So let me execute this. I'll show you. You can see here 102. S name and marks, whatever we are providing. Like this, each time when we insert some record into this table, you don't need to insert the S number for it. It automatically gets incremented. S number automatically gets incremented from the previous value. What is value it will check, and to that one will be added, and that will be assigned to the current row which you wanted to insert. This is about auto increment. Now limit. So what is limit used for? Limit is used to limit the rows displayed from a table. Say for example, we have something called employees table, right? Employees table from classic model schema. Let's switch our schema to classic models now. Let me execute select star from employees first. And you can see there are 23 rows in employees table, right? But I'm not interested to look into all the data from the employees table. I just wanted to look at the first 10 rows from this table. So then we can use limit keyword, limit 10. Specifies that fetch only 10 first 10 records from this table is what it is saying. So you can see here now it says only 10 rows written, and you can also see it here, only 10 records written. When we wanted to restrict the rows to only 10, then we can use limit keyword limit 10. That is what we did here. Now limit can also be used in another way, like we can say the offset here, and then how many records you wanted to fetch. So what is offset is, from the 5th row I wanted to read 5 rows is what you are saying with this syntax. And now you can see there are only 5 rows written, and this is what the 5th record is. Let me execute and show you again. So 1 2 3 4 5, you can see it here, right? So whatever is the 5th record, from that it will actually pick it up, and you can see it here. From there 5 rows will be executed, 5 rows will be written. This is the meaning of limit 5 comma 5. Say for example, starting from 5th row I wanted to have like say for example 10 records. This time we will get 10 records, which will start from 5th row from the table, and from the 5th row I wanted to read 10 rows is what this syntax means. This is about limit keyword. Next, views. So what is a view? So a view is a virtual table based on the result set of an SQL statement. So a view, we can create a view on a table. So we go on creating tables now, right? We used to create tables like that. We call it as a physical table, which actually need to have some space on the, it will occupy some space on the table space and on the hard disk, right? So a view is a virtual table. It will not occupy any space on the table, on the disk. It will not occupy any space, but so it is called as a virtual table. And we can create rows and columns like just like a physical table. We can actually access the view. The fields in view are fields from one or more physical tables in the database. So if we are having wanted to fetch records from more than one table, then we might write like a big select statement, right? So in that case, we can actually create an view, and then we can call this view instead of writing the whole big select statement. So that is what view is used for, and view doesn't occupy any space on the disk. And the most important functionality or purpose of creating a view is security. Say for example, you wanted to provide access to a table for a particular user. Say for example, it has some 10 columns in it, which are like some of the columns are confidential, like which it has some salary information, credit card numbers, like that. And you wanted to but you definitely need to provide access to that user on that table. You don't have a choice there. Then in that case, what we can do is we can create a view on that table with some specific columns excluding the confidential information. Then we can actually provide that view name to the user so that he can actually access that view. That view has only the columns with non-confidential information or non-confidential columns, so that that user can access the other columns. So that is what the main purpose of view is. So let us see this example. Select star from employees, and we wanted to create a view on the employees table. So we already see what's the employees table is, and the employees table data is. It has 23 rows. Fine. And these are the columns in it. Now observe, I don't want it I wanted to have give access on this employees table to someone in my organization, but I am not interested to share all this information from this employee table. So in that case, what I can do is employee number, first name, and job title. This is what I am interested to share the information from this employees table. Then this is how we can create a view for that table. Create view, some view name, any name, as select, this is select statement from employees table. So with this, what happens is this is our normal select query. What are all the columns we wanted to fetch from employees table? Even we can write a condition, where condition, or limit some of the rows, limit to only particular number of rows also we can add it here. Like this is just like our normal select query. You can have it anything here. Only thing new here is creating a view. So what happens if we create it like this? We'll see it now. So we have a view created with this name. So how can we access this now is, we just need to do this. Select star from, okay, let me write the query. Select star from my view. This is the view, right? In the same way how we access the table, in the same way we will be accessing the view as well. You can see it here. I have a view created on 3 columns of employees table. The same data it will refer to. And it also has 23 rows written here. But it has only restricted columns, you can see here. My view. So now you can provide this view to anyone. So they are not even aware of whether this is coming from employees table, or employees table has many columns and they are only viewing 3 columns. Whoever is executing this view, they'll have no idea on that. So this is the main purpose of creating a view, and creating a view doesn't occupy any space on the disk. Remember that. So that's the reason view is called as a virtual table. This is all about view, and we can drop a view like similar to how we drop a table. So how do we drop a table? Drop table name, right? So in the same way we can drop a view as well. So you just need to specify drop view. This is the syntax, drop view name. So if we just specify this, view will be dropped. Now if I execute this statement, you will get an error saying that it doesn't exist. So this is all about views. Next is index. Index are used to retrieve data from the database very fast. So some columns we might be required to retrieve, like frequently we'll be reading some of the columns from the database from some particular table. So in order to retrieve the data fast from the database, we define indexes on some of the columns. Users cannot see these indexes. They are just used to speed up the searches. So you can't actually view it when you are querying it, but it is done internally when we create index on a particular column. Say for example, if I wanted to create an index on some particular column called first name on my employees table. So this is how we can create the index. Create index, some index name on which table or on which column you wanted to create the index. I wanted to create on employees table for the first name column is what we'll specify it here like this. So when we specify it like this, an index will be created on the first name for the employees table, and when we retrieve it we can't actually see it now, as we have like a less number of rows, right? So in usual in real time, if you have like millions of rows, so then you will definitely see the performance gain there while when we create an index on a specific column. It will be retrieved very fast. And the syntax to drop the index, if you are no more interested to have index on a particular column in a table, then we just need to say drop index name on which table you defined it. We just need to execute this. Done. So index will be dropped. So just remember, index are used to retrieve the data very fast. So when we define an index on any column, then reading the data from that table for that column will be fast. This is all about index. Next, last topic is TCL, commit and rollback. So TCL is transaction control language, where like there are two commands, commit and rollback. So what do we mean by commit and rollback is, usually in MySQL there will be a command called set auto commit equal to 1. So what does that mean is, whenever we are working with the DML statements, DML is data manipulation language. So insert, updates, deletes, all this comes under DML, right? So whenever we are working on these type of commands, set auto commit will be 1 by default in MySQL. What does that mean is, we don't need to specify the specify MySQL database that commit this transaction to the database. So committing is persisting the data. So persisting the data onto the database is what we call it as commit. And we have a concept called rollback. Say for example, if we wanted to if we are working on something, and in like if we are inserting some values, let's say for example, let's take this example. So if you created some table here, and you're trying to insert some rows into this table, but in the later point of time, like if you are not interested to insert this, so by mistakenly you inserted these rows into the table, then you can have an option, you will have an option to roll back so that this will not be committed to that database. So this is the use of rollback and commit. So let us see an example now. By default, set auto commit will be 0. That's the reason every transaction whatever we do on any table will automatically be persisted on the database. But when we set it as auto commit equal to 0, so MySQL will not have control on that. Let me do that. Set auto commit equal to 0. Now what happens is, let me create a table first. Create table student, some student 7. And remember, this TCL is applicable for only for DML statements, not for DDL statements. If you are using a drop command, which is DDL command, then that can't be rolled back. So auto commit equal to 0. So what does that mean is, you need to specify what has to be committed to the database and you can what you can roll back. So I created a table now. Let me insert some rows into it. See, I wanted to insert some rows into it. Let me insert first row. Classic model student does not. Okay. We wanted to switch the schema to testdb, and we'll create table here in student 7, and this has to be student 7. Let me insert first row. I inserted one row, right? I inserted two rows, remember. Now let us actually query this table. Select star from student 7. You can see there are two records here, right? But what does that mean is it is not like committed onto the database. You can view it these values will be stored temporarily in some location, and these values are getting from there. Actually, these are not persisted on the database. So how to say that? Let me show you something. Commit. So whenever I say commit, only then that will be committed. Let me commit first. I committed and will execute this command again, and you can see this is persisted now on the database. Now what we'll do here is I'm going to insert third row into this table, and you can see here third row got inserted fine, but I don't wanted this record to be inserted. By mistake I inserted this record. Now I wanted to roll back this. Remember, I didn't commit this transaction, this insert this third row into the database. Now what I can do is I can revert the change, or I can revert the change using rollback command. So see here, I did rollback and you can see it now. It doesn't have that record, third record. And you can clearly see I didn't use any delete command here. So I just roll back the transaction. So that is, it will actually roll back the transaction. It is something like our undo operation or revert. That is what rollback is. So whenever even if by mistake even you delete something from your table, like you can always revert it. Say for example, I deleted some row here from my student 7 table. I was asked to delete this row. What's the column name here? SID. All right. So you can see it says one row deleted, 102. And what happens here? We don't have 102, but I just now realized that by mistake I did this for 102. It should not be deleted is what I realized. Then I always have an option of rollback. So I can just do rollback and do select star from table. The row will be back to the table. So this is the use of transaction TCL commands, rollback and commit. And if you feel that you really wanted this to be persisted on the database, then what you can say is you can delete this and you can also commit this transaction. Now you can see only one record, and even though if you roll back now, you will not get back the record as the transaction is already committed. So you can see it here. I'm trying to roll back or do a revert operation, but it is already committed to the database, so you will not get back. So always should be careful when we are hitting this commit. So once only we are sure, we can execute this commit command. This is the use of rollback and commit commands. And whenever you have this set auto commit 0, only then you need to actually execute this commit. Say for example, if it is by default in MySQL, set auto commit will be set to 1, meaning immediately when you do some DML operation, you can't actually roll back. Say for example, I did set auto commit equal to 1 now. So MySQL will have the control now. It will automatically persist the data onto the database. You will never have the option of rollback now. Let us say for example, I wanted to insert some, or let's say for example, what's the data we have now in student 7? 101, right? Say for example, I wanted to delete this 101. Observe now, I deleted it. I didn't commit it now, but I wanted to roll back it. Let us see first. It doesn't have the record. I wanted to roll back. So I should get back the record is what our expectation is, right? So this is also executed. But if you execute this, you will know you will not see the data here, even though we didn't commit this. So why did this happen is we set this auto commit to 1, meaning we don't have the option of using this rollback. MySQL automatically will commit this transaction to the database and persist the data on the database. So this is the difference between auto commit 0 and 1. So when it is 1, we don't have any control on the TCL commands. Automatically, after executing each command, MySQL commits that command to the database. And when we have auto commit 0, it's our responsibility what to be what transaction to be committed and what commands to be rollback. This is all about TCL commands, rollback and commit.